John. Sorry about that. So creepy. All right. What am I doing? So I'm gonna just clue in the public here. So sometimes amp repairs come back. They come back for a variety of reasons. Sometimes it's like when you bring your car to the mechanic for an issue that only you experience, and you cannot replicate the issue under test conditions, regardless of how steadfast you are with trying to instigate issues. And we do lots of things to instigate issues. We can inject oscillations into the power amp. We can destabilize things. We can create safe and monitored overvoltage conditions. We can create brownout conditions here. We can do all sorts of things just to instigate issues, to agitate things, to shake it up, make the electrons angry. But it doesn't always work out that way when everything tests fine. But let me just say, for you dudes out there who are into the JTM45 and you decide on an amplifier made by a company or I'm not going to say an engineer or designer, because let's face it, these are kind of stamped out cookie cutter amps. You could even see that. You can see the molding creases there. If you decide on a traditionally manufactured and designed JTM45 clone, let's just call it a clone, regardless of the embellishments, if you decide on an amp like that, and even some boxes, don't use the standby switch. I'm just going to tell you right now, you don't need it. Why? What does the standby switch do? Well, it warms up the tubes, somebody in the back said. Well, that's true, it does. But you know what else warms up the tube in a slow, controlled manner? An indirectly heated cathode, such as found in this particular tube assortment. The GZ34/5AR4 is obviously fine to be cold started, along with your EL34s and 6L6s of the world. That's fine. If you want to get into the nitty-gritty details about cathode stripping for tubes that are seeing plate voltages in excess of 9K, you're talking medical equipment or radar equipment, things like that, then you can get down in the nappy dugout of life and sling mud with your friends. But I'm not into that. I ain't about that life. So, don't use the standby switch. Why? Because the rule of thumb for an amplifier running a GZ34 is your first filter cap downstream or upstream, I'm always confused as to where to place that word, cannot exceed 47 microfarads. Why? Well, when you're cold starting an amp, and I've even tried trickle charging these caps, it still happens. Don't go near 47 microfarads. You should probably hover around 30 to be safe. When these things are cold, when your amp is cold, your tubes are cold, all that stuff, when you flip the standby into play mode, the amp is going to be electron starved. It's going to look at things like there's a massive dead short in your power supply, and it's going to suck in those electrons to fill up those caps and charge them as quickly as it can. Well, that's not an issue, but what is an issue is it's taking it from this little guy here, this sad and lowly GZ34, who's got a big job. He's wearing the big boy pants. He's stuck in my tube tester, because spoiler alert, what's coming next. He's got a big job to do, and he's not up to the task when there's a massive cap sitting in his way. So all that juice is going to go ripping through him. It's going to create an internal short or an arc called flashover in the vernacular. It's going to create a carbon track that will eventually become a resistor and will cause issues. How many times can you do it? Nobody knows. They're like light bulbs. How many times can you flip on an incandescent bulb before it flashes out? That's the question. It's one of the mysteries of life, really. So, that said, are there some things you could do to relieve stress from that particular component? Or do you just have to redesign the reservoir situation and the standby situation? Maybe you decide to lift the center tap with the standby switch, lift that sucker from ground, starve your plates or something like that. Maybe that's what you do. I'm not certain. I'm not certain what the best approach is, but outside of paying a dude like me a lot of money an hour to re-engineer a situation that should have been re-engineered after revision 1 in the 60s, the best thing to do is just not use your standby switch. But I totally get having a vestigial appendage sticking out of your amp, not being able to use it. It's like you spend all this money on an amp and you have a control you're not really allowed to touch, so it kind of sucks. So let's take a peek and find out, first of all, let's get this guy out the way, and maybe I could bring that closer so it's not going to be an issue for you guys to see. It's not going to be all grainy. I could bring this in a little bit for you. Is that working? Is that working for you? Not really. It's just as bad. But maybe I can you can see the needle from there. Come on, help me out. This is going to be a hell of a ride, you guys. If you guys are prone to being seasick. But I'm going to cut this one a little short. I got to get to work here. So I've already set up the tester. The primary test that I'm going to be looking for is a shorted rectifier tube causing a blown fuse. Is that what's going on here? Let's find out. So I'll get her warmed up. And we'll find out what's up. And we have filament life. So we have 2 sides to check inside of this tube for shorts. Well, not 2 sides. I can run through the dial with you guys without making it too complicated. Okay, she's good to go. So I'm going to run through here, and maybe you can see this. The light that says shorts. I'm expecting to see it flash in between switch positions and on pin number 8, which is position 8 rather, and on the heater cathode setting, I'm expecting those 2 to light this guy up. That will be expected and normal. So let's go through the positions and see if we can get any flashover. That's pin 8, expecting that. 9. There's that heater cathode position in 10. I'm not showing a short here. Now, John, you were telling me that the club you were playing at had crummy power. There were brownout surges and maelstroms emanating from the sockets. So, perhaps, let's run an emissions check on this guy, and I can check 2 sides of that for you guys. So we're going to look for some nice deflection. That's awesome. So this is still a tube with a lot of output left. Let's run up over to, both halves are looking great. So I'm very happy. All right, now I'm going to run up the heater supply up 1 volt, which is a lot. Let me see if I can instigate a short condition. Ugh, this makes me nervous. I don't like it. So let me actually do this. Yeah, I'll just run it this way. Never mind. Let's get this guy going. I'm only going to bring her up one notch there, and we're going to test for shorts. Okay. Start over. Nope. Boom. Nope. Okay. So for all intents and purposes, this is testing as a healthy tube. At least demonstrably. So we're going to take a peek and see how this amp is behaving through a variety of power conditions. What's causing this intermittent issue? We're going to get a large clue by way of the rear control panel, and we're going to find out which one of these fuses is blowing. Is it the mains or is it the B+? So that'll be indicative. That'll be a bit of a breadcrumb trail for us to follow. But more to come on that, and then just not to put too fine of a point on the capacitor issue, let's take a look at the value of this high quality F&T, and though it's high quality, it's still too much cap for this. Okay, I'm gonna break you guys loose. Hold on. Let's pretend like I didn't just cut the feed there. I said it was too much cap. We're looking at 50 microfarad plus 50 microfarad sections inside of this nice German-made F&T cap. 47 is the max for this rectifier tube. And that wouldn't be a big deal. Going to 50 is super marginal. That's right up on the margin. I wouldn't do it. And it wouldn't be a big deal, except the tolerance could be 30% plus. Do the math. 30% over 50 microfarads. It's way too much cap for this, for that first filtration node. So I would probably suggest bumping it down to like 30 to 40. And even then, I'm going to have to hand select and hand screen the capacitor for this particular position, because it's that sensitive if you want to continue using the standby switch. So just food for thought there. Bye. John, I'm back. Your amp has been reassembled, and we're actually okay. So let's take a peek at this guy back here. Can we do that? Or is my phone going to give me some kind of grief? That guy. This guy. Good Lord, help me. This is why I don't do long form. You see everything. All right. So we are looking. This has been fully calibrated. Let's see how many amps this thing is going to draw from the socket from a cold start. All right. Now, I'm going to let her warm up via the standby switch, the aforementioned appendage of redundancy. Now, the band I want you to focus on is the one that says amps. It's the green one that's pointing to the left. Now, I have no pointer, so I'll just use my haggard index finger. But, hey, where am I at? Oh yeah, this guy, whoop, that little green rainbow there, pointing this way, it says amps. I don't know if you can see it. I can see it. Take my word on it. So, we have her set for a maximum of 4 amps. Boop, there's 4. If that needle here, the indicator, goes over here to the red zone between 3 and 4, there's big trouble in Little China. Terrible reference. Great movie. Now, let's get her switched on. All right, little bump up there as mains power is applied. We have those power-hungry filaments just soaking it up. I have to listen to my voice for a few seconds. All right. Now, if the needle deflects over, if it even deflects over and hits 2, I'm going to create a trickle charge situation for your filter caps. I really don't have to do that, but if you want to use that switch, if you got to use the switch, then I'll sort something out. Okay, here we go. We've settled into well under half an amp. Well under. We're in fractions here. All right, let's get this standby switched off. Let me make sure your amp is not cranked up. So, okay, this chassis is mounted. No, let's see, back against the rear cabinet. That means, good Lord, this could be on 10. I'm not even looking at it. I'm just guessing. Right? I gotta look at it. I don't want to blow anything up here. What if it's on 10? What if it's on 10? It's not. We can go with our gut. All right, let's switch her off. I'm going to get behind this thing. Let's get that centered for you. Now I'm behind the camera fully. You're going to have to see my face. All right. You guys ready? You want to go 3 Mississippis, or let's just do it? Look at that. Nothing. That's nothing. That's great. Let's monitor that for a second. Let's turn up everything to 50%, running along the front of the control panel. And approaching the master. Everything's on 10. Everything's cranked to 10. All right. Let's throw the dummy load on it and run some signal through it cranked up. Let's get some drive established. Some clipping, and I'll get you right back. We'll monitor some more current draw. We're back. The magic of editing. But in reality, I could have done that with you guys there. Could have done that. That's as far back as I can zoom. Is that really as far back as I can zoom? This is very inconsistent. No. This guy back here, got to shoot through the cord there. It's my dummy load, 8 ohms. So, you're not going to hear anything because that will be as a silent speaker, so I can drive this thing with everything on 10. Let me throw everything on 10. All the tone controls. So we'll get the bass frequencies dumping those filter caps and forcing that rectifier to work. Let's get set up with the signal generator. And I'm going to make this a little spicier than normal. What do I mean by that? Now I'm going to drive the input a little harder than you would. All right, let's get her set up. Get us an input here. All right, beautiful. Power on. Let's go with a relatively, let's see, we can do 1K. I don't want to do 1K though. It's not going to annoy me at this point. Let's do, because I want to get more low end. Let's do 400 hertz. Let's do 400 hertz. We're going to do 400 hertz. We'll do a, let me just show you. Do 400 hertz. I'm just setting this up. Why am I showing you guys this stuff? Let's actually do this. Let's sweep. Let's sweep her. All right, I'll take off the attenuation. I'm not going to measure the amplitude too much. I'm not going to worry too much about that. I'll set her around there. So we'll be dumping about a volt into the input. Okay. She's on. She's dumping. And let's get back to this guy. Am I making you guys dizzy or what? Now, let's get her warming up. Once again, let's do it without the standby if you guys are so inclined. There we go. About 0.75 of an amp on initial startup. This thing's cranked to 10, okay? Here we go. Climbing. I'm actually hearing the signal coming through the transformer. That noise you're hearing is the signal going through the transformer. There are no speakers. Unbelievable. All right, so that's all you need to know. It's almost satisfying in a sexual way. You don't believe me? Not about the satisfying part. Got me again. She's still going. Undulating. Undulating. That's gross. I can clearly hear the signal through the amp itself. There's no speaker attached. It's tremendous. It's tremendously interesting. Do you hear that? There's nothing else on. Here's the rear panel of the amp. There's a speaker jack. See, trace the red and black lead down to the dummy load. Interesting. And we're still holding steady. And this is driving the shit out of the input. There we go. No red plating, no excess current draw. Signal is removed. And we settle down to a current draw of roughly, what are we looking at? That's nothing. Like it. There you have it, buddy. You're never going to play that loud. And I actually have the meter there adjusted for 120 wall volts. You know, I mean, maybe I could go higher than that, but I don't want to blow anything up. So there you have it.